We're going to talk about graphing functions in the form of y is equal to cosecant omega x plus b. Now we have a problem here, in that we want to graph the function of y is equal to 2 times cosecant x minus 1, and we want to use the graph to determine the domain and range of y is equal to 2 cosecant x minus 1. Let me read that one more time. Graph the function y is equal to 2 times cosecant x minus 1. We want to use the graph to determine the domain and range of y is equal to 2 cosecant x minus 1. So look at this first initial graph here, which is y is equal to cosecant x only. And here we have basically a sine, an invisible sine function, maybe what that is. Actually, it's acting as a reference point for the actual cosecant graph. And of course, what we're doing here is displaying the actual parabolic type of thingies which are actually hitting or meeting the invisible sine, y is equal to sine x. So we see that, and that it stops here at 1, or first let's just talk about initially. Stops here at -1, and it's also here at what? +1 on the y-axis. See? So what we're doing, we're basically given a graph of of a function. Cosecant is a function, of course, but it's a function that is an inverse of what? Sine function. So sine function and cosecant function are inverses of each other, if you will. So this is why we have this picture, or the similarity of the two graphs kind of corresponding together, creating itself. But basically, we're saying that basically this is not the show, right? The show is basically these little parabolic graphs here shown on this graph. And here we have the asymptotes here, which is x is equal to -pi, x is equal to 0, x is equal to pi, and x is equal to 2 times pi. Just basically trying to explain it to you so where everybody can relate and understand what's going on in the graph. So now that we see the basic y is equal to cosecant x, and again we say cosecant x and sine x are two trigonometrical functions that are inverses of each other. Well, multiplied by 2, it gives a vertical stretch by the factor of 2. And see, this is what happens, you see. So you have this here, you have the -2 here, and of course +2. And this is where basically the graph here is at a point there, and the graph here is at a point here and point there. So we see that. So this is y is equal to 2 cosecant x, if you will. And as we continue on, we're going to subtract 1, right? This is what it says, subtract 1, and that's going to cause a vertical shift down 1 unit. So it's going to shift down some, right? It's going to see, remember it was 2, and now we subtracted 1. 2 minus 1 is 1. So you're going to have a point there, and also it's going to also be -2 minus 1, right? That's going to be -3. So it's shifting down. So here's your point. Your point is -pi over 2 and -3 here. That's so 3 pi over 2 and -3. And you have what? Shifting down to pi and +1. Just like here, if we go back and we look at this, first initially we're at what? Pi over 2 and 1. And of course you have -pi over 2 and -1, and 3 pi over 2 and -1. See? And when we multiply 2 to this here, it's a vertical shift. So now you got pi over 2 and 2, you have -pi over 2 and -2, and of course you have pi times 3 over 2 and negative 2. So we have these points here and this point here. And of course, when you subtract 1 unit, here we go again, we have negative pi over 2 and negative 3 and 3 pi over 2 and negative 3, and of course, pi and positive 1. Now, let's talk about the domain because of all this. The domain of y is equal to 2 times cosecant x minus 1 is the set of all x such that x cannot equal to k times x, because you know that k is an integer, right? And the range also, the range is the set of all y such that y is less than or equal to negative 3, or y is greater than or equal to 1. And that's in set builder notation, of course. And if we use interval notation, it will look like this: from negative infinity to negative 3, which that is going to be a closed circle on the graph, or a bracket, right at the negative 3, because it's inclusive, right? And then we have positive 1, which is inclusive in here, which will be a closed circle on the graph, or a bracket there, to what? Positive infinity. So, of course, from negative infinity to negative 3 in union with positive 1 to positive infinity. This concludes this segment of the video.